Number 1, the weights of cars passing over a bridge have a mean of 3,550 pounds and a standard deviation of 870 pounds. Assume that the weights of the cars passing over the bridge are normally distributed. So whenever we're told a set of data like this is normally distributed, the first thing that we're going to think of is we need to be drawing normal curves and using our calculator. Determine the following probability to the nearest thousandth. So the weight of the randomly selected car is more than 4,000 pounds. So let's draw a picture. So there's my normal curve. In the middle of our normal curve always goes our mean, 3550. I want to know more than 4,000. So where does 4,000 fall? Well, 4,000's over here. More than 4,000 as I'm going to shade up this way. I want to know what's the area, what's that proportion under the curve that way. So the probability of more than 4,000. The probability of more than 4,000, well, we're going to have to compute a z-score because we need to figure out what's the standard normal. So the mean has a z-score of 0. I need the z-score of 4,000. So our z-score is 4,000, the value minus the mean. I want to see how far away I am from the mean, divided by the standard deviation. The z-scores is how many standard deviations away from the mean am I. So I'm going to go to my calculator and type that in. 4,000 minus the mean divided by the standard deviation. So our z-score is about 0.517. 0.517. So I want to know the probability, so 0.517, that z is bigger than 0.517. What's the probability that z is bigger than 0.517? Well, I'm going to go to my calculator. I need to get to my normal CDF, so I'm going to hit second distribution, second variables gives me my distributions, and I want this number 2, normal CDF. The lower bound, well, that's going to be my answer. That's going to be that z-score I just got. You could type it in here as well. The upper bound, it goes on forever. If you look at your picture, the lower bound is 0.517. The upper bound is it goes on forever, so I'm going to put 100 in there. I'm going to put 100, 0, 1. I'm going to paste that. You don't need to have the 0, 1 there. You could have stopped it at 0.517, comma 100. If you have a TI-83, that's what you'll see. So what's that probability to the nearest, let's see what it said to round to the nearest 1,000, so 3 places. If I go 3 places, 0.302. 0.302. So the probability of randomly selecting a car that's more than 4,000 pounds is about 30.2%. So this process always is sketch a picture, put the mean on there, see what value you need to deal with. I want more than 4,000, so I shaded above 4,000. I found my z-score, and then use the normal CDF. I use normal CDF. The second one, the weight of a randomly selected car is less than 3,000 pounds. I'll draw your normal curve. The mean always goes in the center, but 3,000 is going to be less than the mean. So I should be expecting a negative z-score because I'm below the mean. The randomly selected car is less than 3,000. Well, what's less than 3,000? That's shading this way. So I need to figure out what's that probability. So I need a z-score. I need a z-score for 3,000. Well, so it's value minus 3,550. How far away am I from the mean? Divided by the standard deviation. So I'm going to go to my calculator and do 3,000 minus the mean divided by my standard deviation. And I got a negative z-score as I expected because I'm below the mean. I'm about 0.6 standard deviations below the mean. That's what that negative means. So 0.632-ish. So z equals negative 0.632. So what's the probability that z is less than that? Less than negative 0.632. So I'm going to have to use the normal CDF. So I'm going to go to my calculator, second distributions. Never touch PDF. We're always going to use the cumulative normal function here. So we're going to hit CDF. The lower bound, well, let's look at our picture. How low does it go? Well, it goes on forever. So I'm going to type in negative 100. The upper bound, well, where do I want it to stop? That was that z-score I just computed, so I'm going to put answer there. Paste that in. Again, if you don't have the 0, 1 there, that's okay. If you have a TI-83, you're probably just going to have negative 100, comma, answer. And you get a probability of 0.2636 and so on. So to 3 places is 0.264. 0.264. What is the probability of that the weight of a randomly selected car is between 2,800 and 4,500? So sketch a picture. The mean goes in the middle. Between 2,800, which is down here, so to get my z-scores, I'm going to have to compute 2 of them. I'm going to need my z-score for 2,800, which is z equals 2,800 minus the mean divided by the standard deviation. So the numerator figures out how far away am I from the mean. In terms of dividing, tells me how many standard deviations away am I from the mean. So let's figure out what that is. 2,800 minus the mean divided by 870 is negative 0.862 about. So negative 0.862. The upper z-score, our upper z-score is 4,500 minus 3,550 over our standard deviation. Well, what does that come out to be? That's a 0, not a 6. What does that standard deviation come out to be? 4,500 minus the mean. So I'm 950 away from the mean, but how many standard deviations away am I? About 1.092. 1.092. So I want to know what's the probability that purple region there, that z is trapped between 1.092 and negative 0.862. So I want to know what's the probability that my z-score is trapped between those two numbers. And we're going to use the normal CDF function again. So I have a lower bound and an upper bound this time. So I'm going to go do second distribution, normal CDF. My lower bound is that first z-score. My lower bound is negative 0.862. Negative 0.862. I'll try that again. Negative 0.862. The upper bound is my upper z-score of 1.092. I'm going to paste that onto my screen. So the probability that I pick something between there and that purple shaded region is 0.668, 66.8%. So 0.668. The probability that I fall in that middle purple region is approximately 66.8%. Number 2, Dan determined it took 340 seconds to run a mile. He calculated his z-score and obtained negative 2.03. Interpret the meaning of this z-score. So what is a z-score? A z-score is how many standard deviations away from the mean are we? So in this case, Dan's mile time is 2.03 standard deviations below the mean. That negative means he's below the mean, which is actually good when we're talking about running times because you want your time to be smaller. So Dan's time is 2.03 standard deviations below the mean. which is actually good because that means the average is the mean. That's our center. Dan's score here is about 2 whole standard deviations less than that, which means he ran fast, pretty fast. So it's important that you know what z-scores are. It tells you how many standard deviations away you are from the mean, and also how to use normal distributions to find these probabilities by using the normal CDF button on your calculator. We'll practice this again in lesson